All right.
Any other questions?
So when the plant is in the field, you measure the moisture from the bare soil, or you also consider the plants?
So, okay, that's a good question. So we usually, so in this, at first, our main focus is on the bare soil. So if we can, because like in the most projects, people are using the crop canopy as their targets, but we can still take some measurements, take some useful information from the bare soil. So if we have like very low amount of water in a part of the soil, so we can predict it and we can avoid any damages. But later on, probably in the early stages of the growth, so we can extend this project to that point.
In your explanation, you said that your data set are divided into 3 groups: 70% for training, 15 for validation, and then 15 for testing. My understanding was that was supposed to be divided into 2: training and test. Test set data. So can you explain that a little bit? Do you mean that after training the model, you build the model, then you test it on 15% of the data to validate it, and then you now take fresh data for testing? I didn't understand that.
Okay. So it's like a cycle. So the training data set, it's the main part. We have we have 70% of our data set. So we say, okay, we have these experiences. So we can train our machine based on that. But the validation data set is before testing data set. So we only use 85% of our whole data set at first. This is the validation. The validation, so basically, for example, when you have too many variables at first, so you need to make sure which variables have the highest effect. So you don't want to be overfitted. So you use the validation data set to make sure there is no overfitting. So if, for example, if you increase the power of your equation, if it necessarily makes it better for the new samples, or it just works good for a training. Because probably it's high likely to be overfitted if you don't have that validation data set. And when you're done, so between these 2 steps, you can see it goes back and forth between training and validation. And when you're done with that, and you make sure that there is no overfitting, in the next step we have some unseen samples in the testing data set, and we make sure it's a simple part. So we just make sure if we can predict the moisture levels correctly or not.
So I missed the first part of your presentation. You might cover it before, but it was my question that what kind of algorithm or strategy did you use to do a sensitivity analysis to understand which of your variables are the most important in the calibration process? So there are some algorithms out there. So did you use each of those, or?
So for the calibration, so there were some parameters we already knew they have a huge effect on it. So for example, we already knew the ambient light has a huge effect. So as I showed in the picture, so you saw the variability during the when we have the different sunlight intensity. Yeah, you see so it's we are pretty sure the ambient light has a huge effect on it. So for example, we don't change anything, we have the same target, everything is the same. But when the ambient light is changing, so you see that how high is the variability. So we took this one into account, and also we were pretty sure that from the literature review I understood, so the integration time is one of the most important one. So for example, if in the calibration part, that's what I'm saying. So because we need the highest sensitivity in our model, we need to make sure we are closest to the maximum intensity so we can capture the most variability in our measurements. So, but we don't want any saturation. We consider these two parts, and as you can see, we could, we are right now, that's what we want exactly. So we are 90% sure if we go out with this target and we take a measurement, we are pretty sure we're going to get that intensity. And from this intensity, we can understand, okay, we estimate that this target is a white target, is a gray target, or is a soil sample with a 20% moisture content. So that's exactly what we want. So it means probably there are some maybe minor other parameters that affect on it, but because we already covered the 90%, I guess we are close enough.
So, and for your calibration, have you done automatic calibration, or are you planning to do that? Or
Yeah, it's like for
I mean, using some optimization algorithm like a particle swarm or a genetic, something like that, which is really effective.
So for for calibration, no, we don't use those kind of algorithms. We use those for the training, our model. But for the type of algorithm we are using, so it's a closed loop system. So every time we take a measurement, we read the output and we see how how close we are to that a desired integration time or a desired profile. So, and we change it for the next input. So we apply as a game. So we apply it to the input again. So we are changing it over again and again. So it makes it.
Okay, thank you.
Any last